talking about rational numbers and equations. So what I need you to do right now is just copy down the first two problems, number 1 and 2. You don't need 3 and 4 yet, okay? But definitely 1 and 2. We're going to go through those together. I'd like you to wait for me so we can go through them as a class. Even if you know how to do them already, I kind of want to go through a certain process with them, please. Hey, as I go through these today, there are some, like the book will go through how to multiply by a reciprocal to solve these. There will be some teachers that want to see that. I really think I would like to get you through equations the easiest way possible. And as I was looking through your quizzes yesterday, the problems that most students struggled with were the ones where there are fractions. Okay, fractions seem to give everyone a problem. And so my goal today and over the next month as we keep talking about fractions is to make it a lot easier for you to deal with them. So as we go through these, and I'm saying, hey, try this process, please do your best to go through and try what I'm asking you to do, okay? What I want to do for you is to help you to be fraction eliminators. In other words, to get rid of the fraction completely, okay? If you can get rid of the fraction, then the problem becomes a lot easier. Can everyone agree with that? Yeah. Okay. So my process here that I'm going to go through is, the first thing I need to do is to try to make it into a whole fraction. So like if there's a negative sign or there's a variable on either side of the fraction. Now hold on, I saw 4 people right now that are, I started talking about fractions and they're just staring. They're like, not even looking at the board. I need you looking up here and paying close attention. This will affect you all year, not to mention next year and then in advanced algebra, okay? So if there's a negative or a variable, first thing we're going to do is we are going to place that negative either with the top or the bottom number. Now I quite honestly just prefer to place everything on top. So that means the negative sign and the variable. So what I'm going to do is I'm going to change this to negative 2 times x all over 5 equals 4. Okay? Can you do that every time? Yeah, you can do that every time. Mathematically, what's happening, just so you don't think it's magical, some of you may know and some of you may not know, you don't have to write this down. You can if it helps you. The way we get from here to here is there's really a negative 1 hanging out in front here. That's what that negative sign means. So that's negative 1 times 2/5 times x. And if you remember back to just basic fraction work, when you multiply fractions and a number's not a fraction, we turn it into a fraction by putting what under it? Everyone? A 1. Okay? Negative 1 over 1 times 2 over 5 times x over, yeah, we got to put a 1 under it. Is everyone with me right now? Okay. How many are with me? Okay. Negative 1 times 2 times x is? Negative 1 times 2? Negative 2 times x? Negative 2x. 1 times 5 times 1? 5. So that's how we actually get from here to here. Now I don't expect you to show this every time. I just expect that you can do that. Okay? So using that same idea, we're not done with this problem, but using that same idea, I want you to now change this into just a fraction. So move that y around so that it's either on the top or the bottom, however you're going to do it there. Where should it go? Don't wait for me to do it. Do it on your own right now. Write something down. So if you're not sure, guess. Let's see if you're correct. Okay, go ahead and show it to your neighbors. See if they got the same thing. Good. If you're in these groups of 3 over here, yeah, just make sure you're going both sides talking. Okay, where did we attach it? Caden? Next to the 1. So we have 1y over 3 equals 4. How many did that? Okay? Good. Now, we don't have to write the 1 if we don't want to. We could just say y over 3 equals 4. Right? The 1 times y is just y. But if you put 1y, that's okay. All right? mathematically, we usually just write it like that. We drop the 1. Because 1 times y is y. Okay, how many are with me so far? Difficulty, 5 being really tough, 1 being not tough at all. What are we at? Like moving things around. Are we at a 1, easy, or 5, like way hard? Okay, just curious. All right, so just moving things around is all we're doing here. I want you to take 3 and 4, write them down, and move the pieces around so that you have everything on top or bottom or wherever it goes, okay? And then we'll go through and solve them. Your answers matched up with your neighbors. Okay, so someone tell me what this one is. TT, go for it. Negative 2k over 3 equals 8. Well done, TT. All right, anyone else? How about a guy this time? Yes, Keegan, thank you. Good job. 6x over 5 equals negative 12. Well done, Keegan. Okay, 1 to 5. 1 being easy, 5 being difficult. How many are there? Like 1, 5. Okay, so it's getting easier. So it's like way tough. Okay, 1. All right, so now the next part is to eliminate the fractions. Still, you look at this and you're like, dude, that's still kind of tough. The easiest way to eliminate fractions is to find a common denominator. So right now you would look at it and go, well, there's only one denominator. Yeah, so that makes the common denominator easy. Like, what is the common denominator? No. What's the common denominator? Denominator means what? Jake? It is 5. What does denominator mean? The bottom of a fraction. So the common denominator is 5. Why? Because there's only 5 on the bottom. So really the way you eliminate fractions is to multiply by the common denominator. So that means in this problem, we're going to multiply this entire problem by 5. We're going to multiply this side by 5, and we're going to multiply this side by 5. Remember, we have 2 sides. If you can multiply by the common denominator, where you go from here to the next part, the fraction should be eliminated. If it's not, you did something wrong. So when I say I'm multiplying by 5, when I multiply a fraction by a whole number, pay close attention here. A fraction is, how many like shortcuts? Like compact things. Like how many saw the cell phones? How many have ever seen a cell phone from back in like the 90s? Okay, they're pretty big. I can bring mine in. I have mine still from the 90s. It's pretty sick, man. It's awesome. It's like a weapon as well. Not only is it a cell phone, you can hurt people with it if they try to attack you because it's so big. Okay, and then like back in the 80s, they actually had mobile phones. You know, like had this little box you carry around, looked like a little suitcase. That was your cell phone. So like it'd be like carrying your lunch, but it's a phone. Be cruising around with it. You know, they've had people like in the army. They have like the little phone dude that carries the phone on his back, and you know, in the movies, he's the guy that doesn't always survive, unfortunately. Okay, that's in the movie. Okay, but you know, so things get more compact. How many have a cell phone now? Your cell phone's a little more compact. How many are happy your cell phone's a little more compact? Okay. All right. So a fraction is just a compacted way of saying 2 operations. Does anyone know what 2 operations you're doing with a fraction? I've referenced it at least twice in this class this year. Not really. I mean, it's been really fast as I've done it. Yeah. What's an operation? There are 4 of them you know. Well, 4 of them that we talk about all the time. PT? Multiplication's 1. What's another? Someone else. Annalise? Division. Jake? Subtraction. Caden? Addition. So you have 4 operations. A fraction is 2 operations in 1. So when I'm multiplying this number by my fraction, I just told you one of the operations. What's one operation, Jaden? Multiply, yeah. You go 5 times the top. This times that. What's this line mean? Anne-Marie? Annalise? Divide. This times this divided by this. If I multiply 5 times negative 2, what do I get? Everyone. Negative 10 divided by 5. Negative 2. Yeah, if I multiply, now I see 4 of you with your calculator. Dude, put a calculator. Okay? When I multiply a number by 5 and then divide by 5, it's like undoing. It's like saying, hey, tie your shoes. Untie your shoes. Okay? You just did what you did. Hey, multiply by 5, now divide by 5. You're undoing what you just did. Everyone get that? Okay? So if I multiply by 5 and then divide by 5, really I'm undoing and I'm just left with this. All right? These things cancel. We call that in math. So you're left with negative 2x. 5 times negative 2 is negative 10. Divided by 5 is negative 2. What's 4 times 5? Whatever you do to one side, you have to do to the other. It's 20. Notice in one step, I got rid of the fraction. What's our answer here? How do I solve that? Divide by negative 2. And the answer is negative 10. Brendan?
Do you have to show our work like that every time?
Yeah. You have to show work. Yeah. How would you do it differently?
Well, you can do 4 times 5. And then,
So you cross multiply?
yeah.
Yeah. That's a process. The reason I'm not showing cross multiplication here, which I know a lot of you have seen, is because not all the problems are going to look like this. Okay, and when we get to say like, let me get to a different problem here. We get to say like this problem right here, you can't cross multiply anymore. Okay, but if you multiply by the common denominator, then the fraction will still disappear for you. Okay, so that's why I'm not going through that process. If that works for you and you get it, then I'm fine with you using that. Okay. All right. So from here, tell your neighbor what you're going to do to eliminate that fraction. Okay, time's up. Marie, what are you going to do? Multiply by what? 3 times 1? Why are you multiplying by 3 times 1? Okay. Oh, so you're multiplying this by 3. Okay. And the 3 times 1 I assume is like 3 times 1. Okay. And then do what? So you get your 12 here. What happens right here? 3 times 1 is what? 3 divided by 3 is? 1. So when I multiply by 3 and I divide by 3, I'm kind of wasting my time, right? It's once again saying, hey, dig this hole. Now fill it in. You're like undoing what you just did. So hopefully you get into the habit of saying, hey, if I'm going to multiply by 3 and then divide by 3, these things just cancel. Nothing happens. You just are left with this. So there, my answer is y equals 12. Okay, any questions there? Right now I want you to try these two. Get rid of the fraction on your own. Okay? Yeah. Don't get stage fright. All right. Hey, so as Brittany's going through, how many of you multiplied by 3 on number 3? Yeah? When you multiply by 3 and divide by 3, what happens, Jacob? Multiply by 3, divide by 3. What happens? Yeah, they like cancel each other out. It's even. Like nothing happens. It undoes what you did. Okay, very good. How many got negative 12 on number 3? Burrito, well done. All right. Jennifer's going to put up number 4 there. Thank you, Jennifer. Brendan, nice work. That's pretty good handling. Got to admit. Jennifer says we multiply both sides by 5. How many agree? Okay. All right. Okay, everyone rate themselves 1 to 5 right now. 5, you get it. 1, you're struggling with it. Okay. That's neato. All right. So Jennifer says the answer is x equals negative tenaroo. Is that true?
Yes.
Yes? How would we check that?
Plug it into the
Just
equation.
plug in the numbers.
Yeah, we just plug that number in as x, right? We put negative 10 in for x. 6 times negative 10 is? Everyone, 6 times negative 10?
Negative 60.
Negative 60 divided by 5
Negative.
is negative 12. Yep.
I was
All right.
confused.
Hey, very good. You know, I had some more that problems like that I thought we'd do, but I think we're doing okay there. So what I want to do now is I want to try a problem like number 7. It's off your assignment today. This is number 7 off your assignment. So if you put it in your notes, then when we start the assignment, you don't have to redo that problem. This one you'll actually have on today's paper. It'll be part of your assignment. So number 7 changes it up a bit. Why don't you copy that one down and copy down number 10 for me. Okay, in order to do number 7, I have to go into a bit of a story, and it'll be a small story, okay? So let's pretend for a minute you guys, you celebrate Christmas. Okay, some of you do, maybe some of you don't, but let's pretend everyone does for a minute. All right, or you're celebrating something where you get a present. How many have got a present before? Okay, so maybe it's Christmas at your house, and you're like, you cruise down, and under the tree, you see this present. You're like, score. It's like 2 days before, and then, you keep coming down every day, and you're like, oh, all right. And then on Christmas, you come down, and you realize your present that you've seen, that you've been just like, you look at every day, has been cut into a third. Right? Your present is just a third of it. So your parents just like chopped it into a third. Yeah, so this big present has now become 1/3 of the same size. You're like, what in the world? And so you open it up, and whatever you got a third of. Maybe you got this brand new shirt, but they only gave you a third of it. Right? They're like, you get a third of that shirt. They're like, dude, how do I wear that? Or your socks, you just get a third of it. Okay, a third of a shoe or something. Maybe your video game system, they just chopped it into a third. Boom. There you go. Here you go. You get this third of it. How many are with me? Some of you look really depressed right now. It's not a real story. It's not a true story, okay? I hope not. All right. So, that's like this problem, in a sense. This right here is your present. Okay? Now, granted, if you open it up and you found out you got 2x plus 5 for Christmas, you might not be happy. All right? But you have a third of that present. That's what this is saying. You have a third of this box. Whenever you have a quantity, a set of parentheses, that is like an unknown. That whole thing is a box. So some of you have no idea of that. That whole piece you have a third of. Now there's 2 ways to write a third. There's a way to go say, hey, you have a third of this, like we've written it here. Or you have this whole thing divided by 3. So we could write, we have our box here. Okay, the present you haven't opened, but you're kind of bummed about because you know it's been divided into thirds. You know it's been divided by 3. Does everyone understand that? You have 1/3 of it. Okay, you guys are with me on that. Now, if this was like 2/3, which it isn't, it's 1/3, but if that was like 2/3, really you would have 2/3 of it. Now, the way you would write 2/3 is you would write it like that. Everyone see how I've done that? Just whatever's on the bottom goes underneath here. Are we good there? So really 1/3, the reason we don't show the 1 that's sitting up here is because 1 times a box is a box. Right? Yeah.
Is the box acting as like a variable?
The box is it's like a big variable. It's a big unknown. We don't know what's in it. That's like your gift, right? You're just bummed because you know whatever's in it, you only have a third of it. Okay, if it was like a chore list, you'd be pumped. Woohoo! All right, my chore list for Christmas, dude. I only have a third of it. Yeah, that changes some of your attitudes right there. That's a bummer Christmas, I'm just saying. But, all right? So another way to write it is box divided by 3 equals 7. Now we really do know what's in the box. What was in the box? 2x plus 5. So really what we have is 2x plus 5 divided by 3 equals 7. No, I'm sorry if you get 2x plus 5 for Christmas. Your parents wrap up 2x plus 5 and give it to you. I don't even do that to my kids, and I like 2x plus 5. Okay, I think it's kind of cool. But, all right. I'm just saying. How do you get rid of the 3 now? Tell your neighbor how you get rid of 3. Okay, volunteer. Tell me how you can get rid of a fraction. Hey, this is where you're making these connections from what we just did to what we're doing now. Audrey, how do we get rid of the fraction? Multiply by 3, or the common denominator. You multiply everything by the common denominator. Remember, the fraction's the problem. We're going to eliminate the fraction. When I multiply my box by 3 and then divide by 3, it undoes it, right? So if you're staying with the story, your parents divided it into 3/3, and then your grandparents came over and they gave you the other part. They gave you 3 of them. Okay, so you're like, all right, score. You're good now. Okay, now you have the whole box. You're like, all right, I get all of 2x plus 5. Yay. Okay. All right, the story's kind of falling apart. But 7 times 3 is? Got 21. So remember, these pieces, when I multiply this by this, you don't actually have to do the math. You don't have to go 3 times 2x is 6x. 3 times 5 is 15, because you're going to divide that 6x by 3, which gives you back to 2x, and that 15 by 3, which will give you back to 5. So these two things cancel. When you multiply by 3 and then divide by 3, it's undoing each other. So your 2x plus 5 equals 21, and from there, how many know how to solve that? Okay, I think most of you do. You've proven that on your quiz. All right. With that being said, any questions there? This one's a little easier because it's already set up into fifths. All right? I want you to tell your neighbor what you're going to do first on that one. Number 7, I still want you guys to finish up. You can finish that on your own. Obviously, you want to get to x equals whatever it is. But number 10, what do we do? Josh, what do we do? Good. Multiply everything by the common denominator of 5. So we multiply this by 5 and multiply that by 5. All right? Ayla, what happens right here? What am I left with when I multiply by 5? Good. 3a plus 1, right? When you multiply by 5 and then divide by 5, they just cancel. 3a plus 1 equals 10. And then from there, just kind of keep going until you get to a equals, and I'll let you solve that. Okay. Tell your neighbor how you eliminate a fraction. Should not be a problem anymore, I hope. How do you eliminate fractions? Okay, volunteer, how do we do it? Jaden, thank you. Raising your elbow. You can put the hand up, but the elbow's fine. Go ahead. Multiply by? Common denominator. Good. All right. Hey, very good. Jaden's doing the trick elbow thing. All right. Any questions? All right. I'm going to give you about 5 minutes to work on a little more. We just did problems like those on example 2 if you want, but 5 minutes, and then we're going to go on. Some of you to see the story problem, so let's go through that. Number 9, in your class, 4/5 of the students are right-handed. If there are 20 right-handed students, what is the total number of students in the class? Well, if you remember what we did yesterday with the verbal model, we know that 4/5 of our students, 4/5, what's the word of mean in math? Of, if you didn't know, it usually means multiply. So in your class, 4/5 of, that means times usually, of our students. Well, students, if we keep reading, we get to the very end, the question says, what is the total number of students in the class? So it's good to know your variable. Okay? The variable in this case, I'm going to call S for students, or maybe you called it T for total students. Okay? I'm going to call it S. So 4/5 of my total students which I'm going to call, what did I call it? S, so 4/5 of S. And I make my cool S's with little tails so they look like an S and not a 5. It's like a super S. Okay, don't be jealous of my S. Okay, 4/5 of the students are right-handed. Okay, 4/5 of the total students equals right-handed students. Okay? Well, how many right-handed students are there? Notice we've used all this junk. There are 20 right-handed. So we can cross that out now and put 20 in for right-handed. So 4/5, that became that, that became that. Usually in math we put parentheses around it when we substitute it in. We'll talk about that later, but they're not going to mean anything here other than you did that. Hi.
So you have to solve that now?
Yeah, you have to solve for that. And you guys know how to do that. I'm not going to go any further with it. But that's how you kind of transfer it. What I would like to do, though, is I want to go through a few problems that look like example 3. So problems like number 21. So if you copy down 21 and 22 into your notes, those will be the two that we start with. And we may even do 25, but for now, 21 and 22. Look at 21. What's different about this problem compared to all the other ones we've done? Caden?
The bottom number on the fractions are not the same.
The bottom on the fractions aren't the same, and there's more than one, right? So the first thing I'm going to do is I'm going to attach the A. Where does the A get attached to? Yeah? Yeah, so it becomes 1A over 2 plus 1A over 3 equals 5. Mackenzie?
So you need to find a common denominator.
Yeah, so what is our common denominator? Yeah.
6.
6. It's 2 times 3. If you don't know, just multiply the numbers. It's 6. Now be careful here. This is why it's a little different now. You have to multiply every term by 6. That means if you see an addition sign or a subtraction sign, you've got to multiply those things that are separated by that addition or subtraction by 6. So I've got to multiply this thing by 6. I've got to multiply this thing by 6. And I've got to multiply that thing by 6. And remember, when you're multiplying by a whole number, here I'm going 6 times A. What's 6 times A? 6A divided by 2. What is it? Everyone, what is it? 3A. What's 6 times A? 6A divided by 3 is? 2A. And 6 times 5 is? 30. And I know you know how to solve from there. Combine like terms and, okay? You get A equals whatever. Any questions on how we did that? So again, one step gets rid of that fraction. The other way to think of it is you're really canceling. What goes into 2 and 6? 2 does. 2 goes into 2 once. 2 goes into 6 3 times. That's how you get your 3A. Or what goes into 3 and 6? 3 does. 3 goes into 3 once and into 6 twice. That's where the 2A. If you're not good with the cross canceling yet, you will. But for now, you can just go that times that divided by that. Okay, I want everyone to try number 22. First, set it up correctly. Attach the pieces where you need to. And then multiply by your common. Attach this. Remember, I'm going to bring the negative up to the top. I'm going to bring the x up to the top. So this becomes negative 3x over 4 plus 2 equals 1/2. Everyone, what's the common denominator? It's 4, right? If you said 8, that's fine. It would still work, but it's 4. It's not 2. 2's your, at least, that's like a factor. Common denominator, least common multiple is 4. So if I multiply this by 4, this by 4, and this by 4. Well, when I multiply by 4 and then divide by 4, what am I left with? Negative 3x. What am I left with here? Everyone? 8. And what's half of 4? 2. And then from there you solve. X equals, voila. Okay. Any questions there? Hey, just so you're aware, number 25, everyone take a look at it. You've got to change this mixed number to a fraction first. If you're not sure how to do that, you have 4 tenths. 4 times 10 is 40 plus 1. That's 41 tenths. That's what you have right there. So the first step, rewrite it like, okay, you need to know that that's 41 tenths. Okay, you have 4 wholes that are broken into 10 parts. That's 40 plus 1/10 more. All right, finish it up tonight.